So propane. Propane. What do you get propane in? Anybody bought propane? Okay. What is it? What do you buy it in? Cylinder or a tank, right? And does it weigh more when you buy it? Okay. So what does it come in? What form is it in when you buy it? Liquid. It's a lot of times it's called LP gas. What does the L stand for? Liquid. Right? Liquid petroleum or liquid propane gas. LP. Your question?
Is it liquid pressure?
Liquid propane or liquid petroleum. LP. There's liquid. You're buying it in liquid form. What are you using when you cook on it? The gas. So if we have a propane tank, where's the liquid going to be at the tank? At the bottom, because that new law passed. So the liquid's going to be at the bottom. The vapor's going to be at the top. So when I open that tank up and I start letting it flow through the hose and everywhere else out of the fire, the liquid's at the bottom. Now what happens is as I'm using vapor off the top, some of that liquid has to boil into a vapor to replace the vapor pressure that's already there. Does that make sense? So, but wait a minute. Some of the liquid changed state from a liquid to vapor to maintain the vapor pressure. But as it changed state from a liquid to a vapor, let's see, every time a substance, any substance, changes state from a liquid to a vapor, it absorbs heat, which is a cooling effect. So what's happening to that refrigerant, that propane that is changing state? It's a cooling effect. It's absorbing heat. What's happening to the temperature of the remaining refrigerant? The remaining propane? It gets what? It gets cooler. The temperature drops. All right, so the temperature of that tank dropped. Why didn't you guys tell me I missed an entire letter there? That's good. The temperature of that tank starts to drop. What happens to the pressure inside that tank? And the saturation temperature also drops, right? And then so we're using more gas, and then more liquid boils into more vapor, and the temperature drops, and the pressure drops, saturation drops. And the faster we're cooking, the faster this is happening. So the faster I'm changing it from a liquid to vapor, the faster I'm absorbing heat. So as I'm absorbing heat, the temperature of that tank is doing what? Dropping. And the pressure is doing what? Dropping as well. Now, if the pressure is dropping, is that affecting how fast the gas is coming out of the tank and through the hose? Yes. Now, so if I have less pressure coming out of the tank and through the hose, what is happening to your fire? Now, a lot of times it will drop down, and then you have to open the tank more, which allows it to boil from liquid to vapor faster, which drops the pressure faster, which absorbs heat faster, which causes the pressure to drop even more. You see the cycle? You can do this so much until the temperature of that tank drops so much there's ice forming on the outside of it, to where the saturated temperature of that tank drops below 32 degrees. And then ice will start to form on the outside from the air. The moisture from the air will freeze. What's that?
That's happened to me.
Yeah.
It's happened to a lot of people, yeah.
I worked in the oil field, and we use propane torches to heat up, and then when it started to drop, we would have to tip the can over to heat up the bottom of the can so it flows some more.
Yep. So you had to add heat to it to get that, keep that process going. That's a very big deal. They actually make tank heaters, and I wasn't intending to talk about it, so I don't think I have it out and available. Let me just look over here real quick. It may be back there. I don't have it readily available. Let me just check one more spot. They make tank heaters.
Like an electric blanket?
Yes, that's exactly what it is. It's an electric blanket. That's exactly what it is. And it wraps around. Oh, beautiful thing. They make tank heaters. Yeah. And if somebody ever gives you one, you say thank you. Wrap it around, Velcro on it, plug it in, it heats the tank up. Now if I heat the tank up, what's going to happen to the temperature of the tank? What's going to the pressure? Saturation temperature? When we charge refrigerant in the unit sometimes in the winter, or when the temperature outside is lower, we have to use these tank heaters to heat that refrigerant up so the pressure goes up so we can get the refrigerant to flow into the unit. It's the thing that we'll sometimes have to do. But propane is a refrigerant because it changes from a liquid to vapor. Somebody want to Google what the boiling point of propane is?
Boiling point of propane.
Propane has a boiling point of minus 43.6 degrees Fahrenheit.
Minus 43.6. The boiling point of R22 at 0 psig is 0 PSIG, R22. It's at minus, it's just a little bit more than minus 40. It has a pretty similar boiling points, pretty similar characteristics there to R22. So propane is a refrigerant with very similar properties to R22. As it changes state from a liquid to a vapor, it absorbs heat. When in my younger days, on the ranch we had this tractor, it's an LP tractor, Farmall 460. Vance Palmer was the guy's name that had that particular farm. And this tractor, we'd have to fill it up. So it had this big 250-gallon propane tank outside. Had to take the hose and put it on the tractor to put the refrigerant, the liquid, the fuel from the tank into the tractor. And when I would unscrew that tank, and if you guys may have seen this, if you had the tanks refilled, in the old days before you had a basket and a lock and you just swapped them out, you actually had to take it to a propane place, and they put a scale on it weighing the liquid, and they would have this big knob they would screw onto it, and every time they unscrew it, there would be this, and you would see it freeze up. Well, that's liquid propane coming out. Liquid immediately boiling immediately into a vapor. As it changed state from a liquid to vapor, it's absorbing heat, but that would be at minus 43.6 degrees Fahrenheit. So in the days of the tractor, I'd unscrew that, and there would be this little shot of propane that come out and freeze stuff. And I thought that was just really cool. And then I wasn't supposed to, but I found if you open that valve and spray like on the ground, you could freeze, even in the summertime, anything on the ground. And it was pretty cool, right? So
everything was frozen.
you couldn't start the tractor for a little while because you wait for that propane to dissipate, right? You certainly wouldn't want to smoke on that. But it was a really neat effect. But propane is a refrigerant that changes state from a liquid to a vapor, absorbing heat. It just so happens that it's flammable. A lot of BTU content in propane. But it's a fantastic refrigerant. And we use propane in a refrigerant in Europe. And also a lot of the commercial buildings, or commercial walk-in freezers or reach-in freezers in the U.S. use propane. It's a fantastic refrigerant. But what's the problem with using propane? Flammable. Beautiful. Yes, flammable. Refrigerant is flammable. Danger has to have a human aspect to it. But refrigerant, without a doubt, is flammable under the right conditions. To have a flame, what do I have to have? Oxygen. I have to have fuel, heat, and oxygen. So without heat and without oxygen, can I have a fire? Well, inside the refrigeration system, I'm going to have fuel, which is propane, and I'm going to have heat because I got to raise the pressure. I'm absorbing heat, so I will sure have heat, right? Should there be oxygen inside this refrigeration system? No. There should be refrigerant and refrigerant oil. Never oxygen. So if I don't have oxygen inside this system, can I have an explosion?
No.
Even if I pressurize the propane, without oxygen, can I have an explosion? No, I cannot. I cannot have an explosion without oxygen. So there's no oxygen in the system, I can't have a fire. So it's not going to blow up. Now the other question is, well, what if we get a leak here and it leaks out and then there's a flame somewhere nearby? Will there be a problem? Yeah, there'll be a fire, and if it leaks out and settles in one spot, there could be an explosion. But in the unit, the ones that we use here in the U.S., there's a few ounces of propane. The ones in Europe have, a few pounds or whatever, but it's a very small amount. Think about a gallon of water. How many pounds does a gallon of water weigh? 8.3 something. So even in those big units out there, or the bigger units you see, usually there's not more than 8 pounds a gallon of propane. It's not a lot. It's not a lot of propane. Under the right conditions, it still could be a big explosion, but it's a lot of conditions. So with that propane, do people heat their houses with propane?
Yes.
Does anybody have a barbecue pit outside that has propane on it? Have you ever weighed your tank to see how much liquid propane's in that tank? I guarantee it's more than 8 pounds. That's dangerous. Oh my gosh. You have a flammable fuel in a big tank with a lot of it outside your house. That could leak out. That could leak out near a fire and have an explosion, which it does happen. Yeah. People that don't screw them on right or don't do the safety stuff or put this stuff on, right?
Darwinism.
Yeah, that's just true. But it could happen. What about people that have a 250-gallon tank of propane outside with a hose with a non-stop feed of it going into their house? Is that not also dangerous? Yeah. What about also people that have natural gas? They have a flammable fuel in a pipe that goes through the earth that moves into your house with all kinds of fittings that go all over your house. They heat their water with it. They cook with it. They heat their air with it. With a flammable fuel, non-stop. If you cut that pipe, it's not going to stop. It's going to free flow in your house. Is anybody in here? Nobody in here has gas coming to their house, do they? Oh, and you and anybody else? Oh, and you and the whole class. Oh, but that's no big deal. That's a flammable fuel, right?
Put that propane.
We use the word propane. Oh my gosh. Oh, geez, Louise. What about there's another flammable fuel out there. Oh my gosh, gasoline. That's really. Have you guys ever let gasoline on fire? Oh my! Look at YouTube videos of idiots doing stuff with gasoline. If you want to see a funny video, look up Uncle Rob's explosion compilation. Uncle Rob's explosion compilation. If we ever have run out of time, we're gonna watch it. It's one of my favorite videos. That and the guy that has Fiber Fix. Those are my two favorite YouTube commercials. Absolutely hilarious. I laugh every time. I've seen them 100 times. I laugh every single time like I saw it for the first time. Anyways, I digress. But yeah, gasoline is extremely flammable. It's extremely dangerous. Huge explosions with that. And people put that under their kids and fly at 80 miles an hour down the highway with cars right next to them going 80 also. Oh my God, that's craziness.
Smoke.
That could leak.
That could leak out. Imagine if you got into a wreck. Imagine if one of those connections came loose. Right? So, same thing. There should not be oxygen inside of here. Yes, it could leak. Yes, you could have a problem. But if you do it right, there's not going to be a problem. The most dangerous part about propane is when I take the refrigerant out, take the propane out, and I need to work on this. I have to braze these lines up. When I braze these lines, now there's oxygen, now there's heat, now there's a fire going. It could be a problem. But did you guys know that when you braze these lines up, what you're supposed to do in these lines is run nitrogen through the lines while you braze? Even if you're not cooking with propane, you're supposed to run nitrogen through while you braze. Running nitrogen through the copper while you braze prevents oxidation. Sometimes we'll have plumbers in the class, and the plumbers do med gas. Med gas, you have to use nitrogen while you braze to prevent oxidation. Oxidation turns black. It leaves flakes on the inside that will contaminate the entire system. You had a question, sir? Brazing. It's where we take two pieces of copper, and it's similar to welding, where we make them match together. We're going to be doing brazing here. We take the copper and we connect them together so they don't leak. They now become one. It's very similar to welding, but it's just a step down from it. It's a step up. It's a step up from soldering. It's better than soldering. Not quite as good as welding, but it's awesome. It's cool.
It's fun.
Yep. I know right now a lot of you guys are scared about stuff, but before long you guys are going to be brazing. Okay. So when we do the brazing, we're going to run nitrogen, or we probably, when we're practicing, we will though at some point, run nitrogen through, and you can see the difference between oxidation and non-oxidation. So for a long time, we were supposed to be doing this anyways. And a lot of people thought, well, if I don't do it, I don't see the effects of it, so I'm not going to worry about it. But then that stuff builds up. Sometimes it turns to acid. Sometimes it clogs up the filter here. Sometimes it clogs up the meter device. It causes problems in the system. But a lot of people don't do it because they want to save time. Walking to the truck, grabbing a nitrogen tank, and letting it free flow is a big problem for them. So, either way. I'm not going to say that I've never brazed without nitrogen, but I'm going to say I make a very valiant effort to braze with nitrogen almost every time. So, if I'm running nitrogen through the lines, can there be oxygen in the lines? If there's not oxygen, can there be an explosion? Will it be safe? Absolutely. I want to make sure I'm doing it in an open area or a ventilated area. If I'm brazing in a small area, propane's heavy, it settles, it hangs around. It's like that cat that you fed it once. It just hangs around there, it takes forever for it to leave. So if you have a propane leak in an area, you want to open a window, don't turn a fan on because that'll be a spark. Just let some ventilation, let it blow away, let it clear out, and then it'll eventually dissipate and you'll be okay. So that's all it is. It's just a safety hazard. So propane, yes, propane is a refrigerant. And propane has a temperature pressure chart just like that. And they use it, they find superheat, and they find subcooling when they're charging the systems. It's awesome. Absolutely is awesome. So cool.
Propane doesn't deplete the ozone either, does it?
Oh, there we go. Forgot all about that. Propane does, and its accessories, they do not delete or destroy the ozone layer. It's ozone friendly, and since it comes from the earth and goes right back into the earth, it doesn't have a global warming factor, or not much of one if it does have a number. But it's considered environmentally friendly because it comes from the earth. It goes right back to the earth. There is no loss. It's not like we're making a chemical, which is pretty cool. All right, one more thing about propane.